Hello everyone, welcome to engineering study, and today we are going to cover particle size distribution. In my first few lectures we have learned about some inner properties of soil like water content, void ratio, unit weight, specific gravity, and today we are going to learn some of its outer property. That means how you can distinguish the soil by its outer look or its outer dimension. Okay, because if you take some amount of soil in your hand, you will see there are different size of particle present in the whole soil mass. Okay, so we have to distinguish the soil by its size. That's why this chapter is called particle size distribution. And what does that mean? That means is dia of the particle. We have to find out what is its dia. Then we have to distinguish the solids by its size. Okay, and how we will distinguish its diameter? By some sieving. Okay, look at here, 300 millimeter, 80 millimeter, 4.75 millimeter, 75 micron, 2 micron. These are all sieve size. Sieve means in general term we call it as a chakni. Okay, and this 300 millimeter means the size of this from here to here is 300 millimeter, and 80 millimeter means the size of one box is then it will be smaller, 80 millimeter. Similarly for this, size of one box will be 4.75 millimeter. The whole sieve, this all box will have size of 4.75 millimeter. 75 micron, 2 micron, more small. The size of the box will be more smaller in 2 micron. So we have to distinguish the particle by sieving technique, because there are different size of sieves present. So if we sieve the soil will automatically distinguish from according to its size. So now we have given some range to distinguish the particle. First, if the particle size is greater than 300 millimeter, it is called as boulder. 300 to 80 millimeter, it is called as pebble. 80 to 4.75 millimeter, it is called as gravel. 4.75 to 75 micron, it is called as sand. And 75 micron to 2 micron, it is called as silt. And smaller than 2 micron, it is called as clay. So, in our soil mechanics, we generally have to deal only these four type of particle: gravel, sand, silt, and clay. As we can't, and boulder and pebble, as we can't build anything, any structure or any building on the boulder and cable, we have to break it down. We have to make its size smaller. Then you have to convert it into gravel. Then we can build it something on this boulder and cable. So there is no engineering works with these two things, boulder and cable. So we have to only deal with gravel, sand, silt and clay. Gravel and sand called coarse grained soil, silt and clay called fine grained soil. Fine grained means the size will be finer size, smaller size, and coarse grained means bigger size, coarse, bigger size. That means gravel and sand has a bigger size than silt and clay. You can also see it here, 80 millimeter to 4.75 millimeter is called gravel, 4.75 to 75 micron is called sand, and 75 micron means 0.075 millimeter. 75 micron means 0.075 millimeter. Look, that means you can generally guess the how the size of the silt here and how smaller are they, silt and clay, and it is 2 micron. That means 0.002 millimeter. Okay, that means size of one box is 0.002 millimeter and size of one box is 0.075 millimeter. That's why the size is very smaller in case of silt and clay. That's why it is called as fine grained soil. Okay. And now before starting of this chapter, we have to learn first these two terms, that is called retained and passing. Retained and passing. If you start sieving on a sieve like this, and if you put some soil on this sieve, and it is a top view and side view will be like this. Okay, if you put some soil on this sieve, some amount of soil will stay here and some amount of soil will be passed from this sieve. The soil which stay in the upper part of the sieve is called retained soil. Retained. And the soil which will pass through this sieve is called passing soil. Okay, these two terms is important, retained soil and passing soil. And now we are going to the chapter. The first point is soil may consist gravel, sand, silt and clay. Gravel, sand, silt and clay. Gravel and sand called coarse grained soil and silt and clay called fine grained soil. And now if soil is 20%, if soil has 20% fineness, it means there is 20% particle finer than 75 micron. If this term is also important, if the soil has 20% fineness, that means 20% particle will pass through this 75 micron sieve, and the 20% particle consists of silt or clay. That's why it will pass through 75 micron sieve. Okay, and the amount of silt and clay is generally called the fineness of soil. If 20% particle pass through the 75 micron sieve, that means there are 20% silt and clay. So that is, and the amount of silt and clay is called fineness of soil. So if the soil is 20% fineness, it means 20% particle are finer than 75 micron. So this is a general term, and just write it down the how we can differentiate the technique for different type of soil. Okay, particle size distribution PhD. First is coarse analysis, and second is fine analysis. Coarse analysis, coarse grained for coarse grained soil, fine analysis for fine grained soil. Okay, and the for coarse analysis we have to gravel sieving and sand sieving, and for gravel sieving the size of the sieve will be 4.75 mm to 80 mm, and for sand sieving the size is 75 micron, 4.75 mm to 75 micron. For sand sieving 75 micron to 4.75 mm. And for sand sieving there are two techniques, they are dry sieving and wet sieving. And here for fine analysis, that is called sedimentation analysis. Sedimentation analysis is a different technique, we will come later. Today we will cover these two techniques, gravel sieving and sand sieving. Now gravel sieving. As the sieve term are coming here again and again, first you have to learn what our IS code has said about sieving. Okay, IS 461962. For sieve analysis, for different type of sieves, what type of sieves we can use, we have to go through IS 4601962. And the first, the sieve are designated either by its size or by its number. Okay, that means either by its size or its number. That means what we have learned that 300 millimeter, 80 millimeter, 4.75 millimeter. It is the size of the sieve of one box. We can distinguish the sieve by its size or by its number. How we differentiate the sieve by its number? Like the sieve should be designated by its square opening, the number of square opening per inch length. That means if anyone says you that IS 10, IS sieve 10, that means there will be 10 square opening per inch length. If anybody says you that IS 12, there will be 12 square opening per inch length. But generally we distinguish the sieves by its size. 380, 4.75, 75 micron and 2 micron. So now gravel sieving or coarse sieving. Coarse sieving means the particle having size more than 4.75 millimeter. What we have learned that (380, 4.75, 75, 2 micron. In this range, gravel exists. In this range, gravel exists. Coarse sieving are in this range, sand. Gravel sieving means the particle having size more than 4.75 millimeter. That means the particle will not pass through this 4.75 millimeter. It will retain in this part, in this 4.75 millimeter sieve. Will stay here, not it will pass through this 4.75 millimeter sieve. And the particle which is retained here at 4.75 millimeter, that is called gravel. And now, as there is a range 80 to 4.75 millimeter, the gravel stays in this range. So there should be some intermediate sieve to distinguish the gravel more proper way or more properly. So here there are several types of sieves are there in the range from 80 mm to 4.75 mm. First learn that sieves are arranged from top to bottom in decreasing order. That means from top there will be higher size of sieve, and from to bottom the size will start decreasing 80, 40, 20, 10 and 4.75 mm. So in this range there will be 1, 2, 3 more sieves will be there to differentiate the gravel more properly. In the first start of the sieving, we have to first done that oven dry. You have to oven dry the soil, and then you have to put the soil in this 80 mm sieve, and then you have to shake it manually or mechanically at least 10 minutes. We have to put the sieve one by another, 80, then 40, then 20, then 10, then 4.75. Then the whole part you have to shake manually or mechanically by sieve shaker. Okay, then at least 10 minutes, and then the particle which have size more than 80 mm will stay here. The particle which have size more than 40 mm, it will stay here, and it will follow like this. Okay. Now do an experiment here. Okay, let an experiment is done for 100 gram soil. 80, 40, 20, 10 and 4.75 mm sieve. And if you put the 100 gram soil here, and now 10 gram soil retained and 90 gram passed. Okay, and from this 90 gram it will come to next sieve, that is 40 mm sieve, and from this 90 gram 15 mm retained and 75 passed from this sieve, and from this 75 it will come as 20 mm sieve, and then it 25 retained and 50 passed, and like this 20, 30, 30 and 0. but we have to do it in a tabulation form. Size 80, 40, 20, 10 and 4.75. Weight written 10, 15, 25, 20 and 30. Percentage weight written, total weight of the soil 100 gram, 10 by 100, that means 10%, 15 by 100, 15%, 25 by 100, 25%, 20 by 100, 20%, 30 by 100, 30%. And cumulative means first 10%, then 10 plus 15, 25%, 25 plus 25, 50%, 50 plus 20, 70%, 70 plus 30, 100%. And now percent final, that means the size of the particle that will pass through 80 millimeter sieve. So the percentage particle retained 10%, then 100 minus 10, 90%. Look at here, 90%. 90% particle are final, that means 90% particle are passed through 80 millimeter sieve. And then 100 minus 25, 75%. Look at here, 75%. That means 75% particle passed through 40 millimeter sieve. Similarly, 100 minus 50% minus 50%, 50% passed final. 100 minus 70, 30%, and 100 minus 100, 0%. No particle will pass through this 4.75 millimeter sieve. So we have to do this tabulation after the sieve analysis in your lab book. Okay. Now sand sieving. And for the sand is the particle will pass through 4.75 millimeter sieve but retained 75 micron sieve, that is called as sand. Okay, and the techniques are same as we have already done gravel analysis. The technique are same, but the sieve size will be different. The range is 4.75 to 75 micron. We have to arrange the sieve in a decreasing order. First 4.75, then in between this range we have to put some other sieves are there to distinguish the sand in its size, as its size. 4.75, 2 micron, 1 micron, 4.75 millimeter, 2 millimeter, 1 millimeter, 600 micron to 75 micron. As there will be different type of sand, we have to differentiate the sand on the basis of its size. So we have to put different size of sieves in a decreasing order. And the technique and the tabulation is same as per coarse sieving or gravel sieving as we have done earlier. Okay, so we are not going to repeat that again. And now two notes is important here. And the first is in the sand sieving we already know that there are two techniques: wet sieving and dry sieving. You have already noted it down. Okay, in wet sieving you have already noted it down. Just go through your note. And wet sieving and dry sieving. And for wet sieving, what is wet sieving? If silt and clay present in sand, we have to wash the soil to remove the particles. That is called wet sieving. If silt and clay present in the sand, as silt and clay has some sticky nature, some sticky property, it will stick to the sand particle. And as for proper analysis, for proper sieving, we have to first remove the silt and clay. That's why we have to wash the sand by a 2 gram of sodium hexametaphosphate in 1 liter of water. As we have to wash the sand, that's why it is called wet sieving. If we don't have to wash the sand, then it is called as dry sieving. Okay, so this two note is important. Okay, so write it down and thank you for today. In the upcoming lecture, we will cover consistency of soil.